Today. Now, everything we've done so far when we were solving triangles has required right triangles for us to use SOHCAHTOA or Pythagorean theorem, or etc. Today, we're not going to have right triangles, but today we're going to be dealing with, in geometry you learned that the bigger the side, the bigger the angle, and vice versa, right? So like for instance, I'm just going to draw a quick little example. If this was a 95 degree angle, 25 degree angle, and 70 to 60 degree angle. Now let's call these sides A, B, and C. Which side has... Yes, ma'am? Yes, you may. Which side is going to be the biggest on that triangle? A. Which side is going to be the smallest? Okay, excellent. It is from that logic that this comes into play. This is the law of sines, and it is the basis for everything we are doing today. This is the law of sines. Some people freak out if they accidentally mix it up, but if you accidentally flip all these over, it doesn't change anything. A over sine A, B over sine B, C over sine C. I actually always got that backwards in high school, and my teacher always yelled at me, but now that I know it doesn't make a difference, I'm going to go back to that. I gave you rewards that already, didn't I? I never did. Well, it's not going to be the difference, but I'll figure out something. Okay. Now, one guess about what our calculators need to be in for this problem. Degree mode. There's degrees in the triangle, so we need to be in degrees. So, to use the law of sines, there's one thing you absolutely must have. You must have an angle and the side opposite that angle. You must have at least one pair in the problem. So here, 96 and 12, the side directly opposite the 96. And we're going to set up a proportion to first solve for side A. So that's sine of 96 over 12 equals sine of 42 over little a. Who remembers how to solve proportions? Everybody, good. Cross multiply. A times sine of 96 equals 12 times sine of 42. Now remember, sine of a number is just a number. So you can divide by sine of 96. And then you can punch that whole dang thing into the old calculator. So let me make sure I'm in degree mode, which I am not. Okay. 12 times. Now, if you don't want to deal with a whole bunch of parentheses and everything, I would do it one step at a time. 12 sine 42 divided by sine of 96. Enter. And A is 8.07. It says nearest tenth, so I guess 8.1. 8.1. Now, when it says solve the triangle, that means we have to find everything that's missing. So what's the easiest thing to find next? Yeah, the angle. And how am I going to find that, Chris? Yeah. They all add up to 180. So what's that going to be, someone? 42? What do we know about isosceles triangles? Wait, dang it. I said it backwards. Right. So what's B going to be? If the angles are the same, then the sides are going to be the same. That's the entire basis for the law of sines. So we actually, most of the time, that's not going to be the case. And then you would have to go and do the law of sines again to find this side. But as it turns out, we started off with an isosceles triangle, so we didn't have to. Law of sines. That's pretty much the entire lesson. We're still going to do the next 12 slides, but questions about that problem or the fundamental of the theorem or anything? Oh yeah. To use the law of sine, well, today they'll all have this, but like on your test, this entire chapter I'm going to be showing you more and more things to solve triangles with. So on your test, you're going to know that you need to use law of sine if you have a side and an angle pairing. If they actually give you a match on the angle and the side opposite. That's when you're going to use law of sine. Yes. Yes. Next question. Okay. Do I have a side angle pair? Yes. 38 and the 20? So you know that's how you have to start out. Sine of 38 over 20. Now what do you want to solve for first? Okay, so sine of 102 over c. You guys do your whole cross multiplying thing. Then someone raise your hand when you think you've got it. Now remember, logic should prevail. You'll know you have a wrong answer if this side isn't significantly bigger than the 20 because the angle is significantly bigger. Well, I say significant. I don't know how much bigger, but it should be bigger. So if you were to get something like 16, that should set off a red flag because the bigger angle should have the bigger side. How do you just go down? Will somebody verify that? Yay. 31.8. So what's our other angle going to be? 40. Now, before we find side B, who has a prediction, a guess about what side B is going to be? Why 21? Exactly. This is slightly bigger than this, so its corresponding side should be slightly bigger. That's perfect logic. So here we go again. Now, why can't we use Pythagorean theorem? Not a right triangle. Very good. Sine. Now, at this point, you can use either pair. You could use sine of 102 over 31.8 to start your proportion. However, this is the number that's been rounded in the problem. I always like to start with the original that provided us. That way we're not using a rounded answer. Because when you use a rounded answer, your margin of error becomes a little bigger. So, sine of 38 over 20 equals sine of 40 over b. Cross multiply. Tell me what you get with one of these. Jalen, I think I'm going to ask you. Is that a question or do you have the answer? Yes, ma'am. We subtracted from 180. 180 minus 102 minus 38. Yeah, they'll always add to 180 degrees. And even though, in theory, you should be able to find an angle using the same method as finding a side, there's a problem with that, which we'll talk about tomorrow. So today, all the angles you'll be finding, you can just subtract. You won't have to use this formula for an angle. Yep. 20.9. And Justin was really darn close. Questions about anything you see on the board? This is a beautiful formula because it sets up the same way every time. Bless you. I know you just coughed. I'm just a blesser. Anyway, it sets up the same way every time. You're always going to cross multiply, etc. Questions? No? All right. Then let's skip on ahead. Do I need to stay on the slide? Okay. Now here, they're not going to draw it for you. That doesn't change anything. Doesn't change anything. Just notice, in every single problem, they gave you a pair. AA, BB, CC. Darn. Why 15? Why do you think 15 is not going to be a problem anyway for us? That's true. That's right. Both of those are true. It is going to be isosceles, but you can also just get C by subtraction, which would be what? 50. That's right. So, now notice, solve each triangle. That means tell everything that you don't know, the missing angle and both the missing sides. Is there a particular example someone would like to see? I want to do one of them, so somebody pick one. I heard multiple 13s and one 11. You overruled. All right, 13 because the numbers are bigger. So where's my pair? How am I going to set this one up, Jordan? Okay. You want me to label everything? C, A, B, A, B, C. Sound like a cheerleader. All right, so C is 35. C is 200. A is 115. And that's it. Okay, now Jordan, how am I going to set this up? Move in and that's right. Cross multiply. Any theories about the answer? Oh wow, how specific. I'm going to go 124.9. Let's see who's closer. I know. Oh, my wife and I were on YouTube the other night because we were really bored. And it was a video called Worst Guess Ever on The Price is Right. Oh, it was hilarious. It was like a couch and two scooters. And this guy's like, $1.2 million. And the thingy only goes up to 6 digits. So Bob Barker's like, is that your real answer? The guy's like, no. You could tell it was, though. He goes, what's your real answer? $250,000 for a couch and two little scooters. The other woman's like, I'll bet $1, Bob. And she won. I don't know if you've never watched that show. You either have to be closer, or if someone goes over, the other person wins. So she's like, I'll go $1. It was hilarious. Anyway, who found A? Yes, sir. 300 what? Got it. All right. So, what's my angle B going to be? 30. And you can do the same exact thing to find angle B. Sine of 35 over 200 equals sine of 30. What? 176. Although I'm 0 for 1 with this strategy. 174? Is that your guess, or is that what it is? Dang it. I am horrible today. Yes. Sure. You may just start on the next problem? Or, actually, I'll tell you what. I can make just that bigger. Just, uh-oh, I'll be right there. Is that better? Okay, questions? Sure. Any pairing you want. In fact, we're going to be doing something similar to this in the next few days, and I actually discourage people from falling in love with the letters A, B, and C, because even though it doesn't matter so much for this formula, because they're interchangeable with their order, there's going to be stuff we're doing in the next day or two where those A's, B's, and C's are like all going to like change all the time. So like we just change the formulas like X, Y, and Z. The letters are completely irrelevant. Just any pairing that you want. Okay. Any other questions from this slide? Okay. Whoa, just kidding. That's not the end of the lesson. What? What? It says we have 8 more points left. Hold on. Pause. I must have accidentally cut something off of this.
Yeah.
Okay, here we go. I don't know what happened right there, but we're back. All right. No, it's not. Now, we're going to do the exact same thing, except we have multiple steps we have to do now. We are asked to find A, right here. Now, we're still going to be using the law of sine, but in that triangle, all we have, what's this angle right here on this triangle? Sam, how'd you get 4? Exactly. These word problems, you're going to have to use some logic. If this angle is 32 and this angle is 28, then that little one in between them is just the difference between them. So, here we go. We are going to have to set up. So this angle right here, the one we need, is 4 degrees. Which means we're going to have sine of 4 over little a equals. However, we don't have anything else to work with. We don't have any way to finish out that law of sine. So what we're going to have to do is work on a different triangle pieces, and maybe, here's the game plan. Anytime you see one of these pictures, here's another triangle. If we can figure out this side of this triangle, the bottom one, then we'll still have that side for the other triangle. And then we could use the law of sine by using some angle thinking right here. If this is 35, what is this angle? How'd you get that? Exactly. The linear pair postulate from geometry stated that all linear pairs add to 180, straight angle. So 180 minus 35, which say what? 145. All right. Now it tells you what this angle is. So let's go ahead and finish out this small triangle. What would this angle be? Ashley, is that you? Good job. 34. Now we have 3 angles of this triangle, 145, 34, and 1. Do we have enough to set up any kind of law of sine to find that side? We have all 3 angles. Do we have at least one side? Yes, we do. We have this side right here. Now, which angle is directly opposite of this side? 34. Very good. The hardest thing about these problems is seeing what goes where. So, we have to start with that. Sine of 34 over 450. Now, we need this side over here. So, which angle is opposite of that? 145. Now, let's just call it x over x. Cross multiply. Tell me what you get. 2-part law of sines problems. What was it? 2.4? Make sure you're in degree. Did you multiply by 450? 268 sounds about right. Does anybody get something different? I have a calculator. I don't know why I'm just not doing this myself. Not that I don't trust you all. Because you know I do. You're off right much more often than I am. 450 times sine of 145 divided by sine 34. I got 461.6. Would somebody like for us to look at that if you're still getting 260? 461, is that what you got, Latifa? Alright, 461.6. So that's going to be this. Alright, now, we're almost there. We've got another side. But what do we need in order to finish up this law of sines? Don't we need this angle here? How can I find that angle? Give you a hint, it's extremely similar to how we found the 2 on the other triangle. I hear so many people whispering that I can't really tell what you're saying. Exactly. 180 minus 34 will give you this angle, which is what? 146? Because it was 34? This one was 34. So 180 minus that is 146. What was this? 4? So 146 plus 4 minus 180, 30. So there we go. Sine of 30 over 461.6 equals sine of 4 over A. And go. I'm betting, I'm going with 45. Nate, you gonna put in a guess?
Oh, which side?
A, I'm going for 45. Dang you, Ryan. But you undercut me. 64.4? In your face. 64.4 units. 64.4. These diagrams are just using the law of sines multiple times. That's all it is. Now, the only reason this looks complicated is because I have all these arrows going everywhere. And it looks more like some kind of Venn diagram, but science diagram. I don't know science. I'm gonna stop trying. Any questions on this problem? Yes. Yes. Alright, well, what do all triangles add up to? 145, 1, and then we got, we got this angle? Other questions? Moving along, moving along. What is this? I forgot we were doing all this stuff today. Okay. I really wish I had another example. Ooh, I do. It was going to be tomorrow's DOM, but you can just do it right now. There you go. Boom. Find edge. We'll be fine. Don't you worry. In fact, I know exactly where you get this tomorrow's DOM. I've only had one really bad one. Another monster one. Someone who didn't know what we were talking about. You're solving for H. Monster John. Alright, first thing you should have figured out is that this angle right here is 113. Therefore, via subtraction, I believe you found that this was 24. And I believe the setup I saw in a lot of people's papers, which was correct, was sine of 24 over 312 equals sine, let's call this x, sine of 43. Oh, that's probably where you went. That's probably where you're getting something different, because you used sine of 113, didn't you? Didn't you use sine of 113 instead of 43? Yeah, that's what it was. Sorry, I didn't catch that. I should have caught that. Alright, so what'd you get for x once you did that? Got it. So, from there, now, being a right triangle, from here you could have used SOHCAHTOA if you wanted to. From 67, that's opposite and that's hypotenuse. Or you could use law of sines. The only thing about using law of sines in a right triangle is, what is sine of 90? It's 1. So, it ends up, it's kind of funny, it ends up being SOHCAHTOA anyway. Because you get sine of 67 equals h. Now when you cross multiply, you get sine 90, which is just h, equals, where am I? 523 times sine 67? And h was what? 41. Oh, or 81.5. Oops. Question? Only one more thing to do. Questions about geese? All right. All right. Lastly, would you agree with me that the area of a triangle is 1/2 base times height? Good. Well, would you also agree with me that if we were just looking at this right-hand triangle right here, would you agree with me that sine of A, according to SOHCAHTOA, would be h over c? Do I hear an amen?
Amen.
All right. Now, if we were to solve for the height, because let's say they don't give us the height. So if we were to solve for the height, wouldn't that just be h equals c sine of A? Yes, it would. Therefore, by substitution, the area of a triangle could be given by the formula 1/2 the base times c sine of A. Just substituting this in for h. Here is that formula written out for you more formally. Now, you do not have to write this formula 3 times. It's the same formula, just written 3 different ways. The only thing that's different, notice, you use 2 sides. Did we use side A? No, but we used angle A. You're always going to use an angle and the sides on right around that angle. You're never going to use a side angle pair like the law of sines does. So, 2 sides in the angle that's not one of those sides. 2 sides, notice, A, no A, C, no C, B, no B. If you pick up on that, then everything else in this formula is easy. 1/2, 2 of the sides times sine of an angle. One-half times 2 of the sides and the sine of an angle. Now, let's say they were to give you everything. It doesn't matter which ones you use. In fact, let's jump back to a previous problem and find the area of one of those triangles. And I'll show you, it don't matter. It don't matter. Again, you don't have to write down all 3 of those. They're the same formula. Again, and again, and again. All right. Let's look at one of them we did more neatly. This one. Now, pick any 2 sides you want to use in this formula. I heard B and A first. So, B and A, 20.9, 20. Which side did we not use? So we're going to use its angle, sine 102. That's the whole thing about the formula. You pick any 2 sides and the angle between them, essentially. The SAS thing, back from geometry. You take any 2 sides and the angle between them, and that's how you use the formula. And you would get the same answer no matter which 2 sides and angle you pick. That's the beauty of this formula. So somebody punch that in. Tell me what you get. 2,000 and what? Units squared. Very good. I assume that's right. I didn't work it. But it wouldn't matter what we chose, we would get that. Really? That seems... Oh, no, that is right. Is it? Is it? It does seem kind of high. Because one... What'd you get? Well, I know sine 102 is less than 1, and 1/2 is cutting it in half. Let's see. 20 times 20.9. Enter. Times 0.5. Times sine 102. And I'm also getting 204.4 units squared. No biggie. 204.4. Now here's how your problems are going to be given to you. Let me click way on back over here. Here are yours. And they really made it easy for you. And I really hate them for doing it. In fact, no. No. Instead of doing it like that, we don't need to be spoon-fed stuff. Instead, today, every triangle you solve, I just want you to give me the area of that. What a great attitude to have about it, people. Yeah! All right. That's all I'm going to tell you today. I'll teach you that other thing. However, I'm going to have you start with that And I may be adjusting this in a second, but you go ahead and get started on that. And I may be adjusting this assignment. This is 6.1. 6.1. Hold on. I'm adjusting the numbers. All right. No. I'm going to change this.
No.
Calm down, people. I'm not done yet. Now, please make sure you understand what I want here. For 2 through 14 every other even, I also want you to include the area for those. That's only like 6 problems. And then... Oh, I guess there's only one more thing. That's it. Just that. Really? So it's that 40 and 42 was the all man? Yes, 6.1. That is your assignments.